Hi, welcome to the session on multiple ascending dose study non-compartmental analysis using PumasCP. In this video tutorial, I'll be showing two scenarios. One is a multiple dose study wherein we'll be using that to perform NCA, and other is a multiple ascending dose study with intracohort dose escalation. So two different study designs, and let's look at how we can be prepare the dataset and also perform NCA using PumasCP today. So first, let's look at the multiple dose study. Let me show you the dataset first quickly. So here we have a molecule PI 4101, and plasma concentrations have been collected for both the parent and the metabolite on day 1 and day 14. So basically we have other samples as well, but these are just rough, and we will not be using that because we just needed samples for NCA currently in this exercise. And we if we look at the data set, we have other columns such as dosing time, plasma concentration sampling time, and also nominal time as well. So we have some data wrangling to perform before we move directly to uh, starting a task. So let's click on done, and we'll perform some basic transformations to prepare the dataset for analysis. Click on transform. So if you look at the dataset, we don't find a root column, right? So we have the amount, but we don't have the root column. So let's click on define root and choose extravascular. This drug was a oral drug, so I'll just mention it as extravascular over here. And the next step, we do have the visit column over here, which has day mentioned as both text and the number. So we'll just need the number over here rather than having everything here. So let me click on derive and say we can use the split function to use the visit column that is already present, and I'm using a delimiter called space because we you see that between day and the number 1 we have space between. So we can use the delimiter saying there is a space between the characters, and I need the second part of the value that is there in the column. So this gives me the number in each row. So there I create a column called day now, and you see that now a day column is created, but it is a string variable. That means it is not considering it as a number. So let's use the convert function and click on select day and then choose type as number. So this converts this column to a number, helping us to go for further analysis. And now, as I mentioned, we don't need all the days or samples from all the days. Just day 1 and day 14 for both parent and metabolite would be sufficient, right? So, and also one more thing, if we look at over here, we do have some concentrations that we need to include other than day 1. So here day 2 pre-dose is nothing but day 1 24 hours, right? Because this is administered every day or every 24 hours. So we need to include this also in the data set to complete the profile, and we would get a complete understanding of the day 1 administration, right? So I would include day 2 and day 15 pre-dose as well, so that gives me a complete profile. So I would use the filter function to say day in a vector, so of numbers 1 comma 2 comma 14 and 15. So this is nothing but I'm telling to filter all the rows in the day which has these numbers. So I'm using the filter function, and next step, this day column is there, but still I would need a period or an occasion column to differentiate between day 1 and day 14. So I would click on derive and say my day, if it is less than or equal to 2, that means 24 hours of administration. Value should be 1, else it should be 2. So this would, I just call it as period over here, and you see that now I have period column similar to what we can call it as an occasion column as well. So period occasion 1 and occasion 2 can be easily differentiated now. The next step, let's calculate the actual time for analysis. So because now we have the nominal time that is shown here in the ATPT column, but we need the actual time by calculating the difference between TRT SDTM and ARF DTM or PCDTC. I'm sorry, yeah. So over here, let's calculate actual time by using PCDTC subtracted from TRT SDTM. That means treatment start date. I'm subtracting the plasma concentration date time from the treatment start date. So this gives me the actual time. And in the previous data wrangling videos also I've shown when we subtract dates, will be in we need to convert it to hours. You can look at that, why it is important in the previous videos. So I'm using the millisecond to divide it by whatever value I get from the subtraction and multiplied by 1000 into 60 into 60. So over here, this would give me the value of time in hours. I would name this column as time TRT. Okay, that's a typo over here. SDTM. So I would now get the time variable as this, and you see that there are few negative values over here. Time that is that means there's a pre-dose concentration, right? So let's make it 0 for now for analysis. I would use the derive option again. Say if time is less than 0, then the value should be 0, else the time as it is. So I would give the column name as time itself. So this will replace whatever we have in the same column. So this will uh, give us the required value. So over here, so you see we now have the time value ready. And now let's also calculate time after dose. That would be important to plot and also to use it for further analysis, right? To do that, I would use the group by function and group these subjects by the ID and the period, that is two occasions, and also we have two analytes, right? Both parent and metabolite. So I'm grouping them by the param-CD column. So over here I'm now grouped these subjects, and now let's calculate the the first time. So basically I would need the first value of in each subject of time as a separate column. So I can do that by using the first function and calling time. And here in the previous data wrangling videos also I have shown when using what kind of evaluation style to be used in what kind of uh, scenarios. So this is now, let's say if I just say the column name as f time and leave it as it is, um, let's just wait a second for it to run. So basically I need the first values in each grouping that I just performed. So I've grouped all the subjects based on this, right? So let's look at the value. So does it give me the output that I require? So I wanted 0 on whatever value was there here in the time to be printed on all the rows. That means that is the first time for the subject, but that is not the case. So in the previous videos you can watch why this by row and by column evaluation style is important. So when I change this to by column, I would get the necessary output. That is the first time in each of these subjects. I have highlighted why this is important in previous videos. Please watch those. And now let's calculate time after dose. So now my time after dose is time minus f time. That means the column name would be TAD. And this gives me the time after dose column. I guess there's one more column that is missing, that is my the interdose interval or the frequency of administration. So I would create a column again and say interdose interval is 24 hours. So this again creates one more column. Now I now have it. Now this data is ready for analysis. So let's move forward by clicking on done. So now the dataset is ready for analysis. You see the derived dataset for the multiple dose study. Click on run a new task and choose this as scenario 1. I'm just making it up, so just we can differentiate between the analysis, and I'll click on done and choose the derived dataset. Again click on next. So let's choose some important columns. So my observation column was in eval, concentrations, and I would need to group them by other values as well. So it is grouped based on period. So I would choose columns like PumasCP because that defines the analyte. So we have both parent and metabolite. Yeah. So now we have both parent and metabolite measured in both each of the period 1 and period 2, or occasion 1 and occasion 2. You see that the now analysis is already done and you have already the results that is seen. I mentioned we need to add a column called II, interdose interval. This is the first time that we are introducing this column in these video series. Previously we did not show this, right? So this is important when you have multiple dose studies. You would need to mention the interdose interval. Unless you add this column, you would not be able to derive parameters like C average, C tau, AUC tau. So all those would come based on your tau value, right? So this is important to be mapped when you're doing multiple dose analysis. Please note that. And next, let's directly move to step 7 to look at how our results are seen. So this way I would get my summary parameters for each of the analyte and also in the different occasions. So this is basically my day 1 Cmax and day 14 Cmax in each of the metabolite. So this way I can perform the analysis for multiple dose study datasets. I can click on complete. So ensure you can add the nominal time column as well here, because you have the time column that is actual time here. You can also add the nominal time that would be taken as a reference for all your plots and tables. That will also be important. You can add that as well. So the other scenario that I wanted to show was the multiple ascending dose, wherein you will perform an intra-cohort dose escalation. So what is the study design? Let's look at the dataset first. So we do have 4 different cohorts here. So this was derived from a study. I'll show you the plot of the study design over here. So we have 4 different cohorts. In each of the cohort, different doses were administered. Cohort 1 and 2, 30 and 10 milligrams were administered, and cohort 3, you see that on day 1, 10 milligrams, till day 7, 10 milligrams were administered, and after that it was shifted to 30 milligrams, then to 60. So, and same way for cohort 4 as well, started at 10, after 7 days or after it reached steady state, it was shifted to 30, and then till 100. So samples were collected in all these cohorts on day 1, as well as when these doses were administered, that is 30, 60 and 100, steady state samples were collected. So we are now introducing again in these video series another column that would be important for you to go forward with analysis is the SS column. So because these samples were collected at steady state for 30, 60 and 100 in these cohorts, you would need to mention the SS column as 1, and else it should be 0. So I'll show you how does it look like. So where we have, so you see this is the column that I was just talking about. You need to introduce this column while preparing the dataset, saying this is just a numeric indicator. The value should be 0 if the concentration that was measured was not in steady state. It should be 1 if the concentration that was measured, if it is in steady state. So basically it's just yes or no, or Boolean type of a column that you can easily call it. So we have, like I said, 4 different cohorts, plasma concentrations measured on day 1, day 14, day 21 and day 28. for different cohorts. So we have the data set now. Let's click on done, and let's perform some again basic transformations before we go forward. Click on transform. So you think we have all the columns, right? But we don't have the II column. That would be important for multiple dose, right? So let's create an interdose interval column. I would say the value would be everyday dosing II, and I get the II column over here. Next step, I would look at the dataset again. Yeah, so there is this amount column that has all missing values that is not needed. I'll just take that out for now, because if it is more cleaner, you would easily understand that instead of having some other columns in the dataset before you go for the analysis. So now we have just removed that amount column over here, making it more cleaner. And let's add the root column as well, that is not present here. I click on derive root, choose extravascular. So now the dataset is ready. Let's click on done. So now we have the derived dataset, that is from the intra-cohort dose escalation. I'll click on run a new task, choose this as NCA scenario 2. Let's go forward. Choose the intra-cohort dose escalation dataset. Click on next. So we have all the primary variables already mapped. Let's group them by cohort. So we, as I said, 4 different cohorts we do have, and let's group them by the day of sampling. So as I was mentioning, for cohort 1, day 1 and day 14 was measured. Cohort 2, day 1 and day 14 again. Cohort 3, 10 milligrams when administered. It was measured on day 1, and then it was 30 milligrams was administered on day 7, and sampling was done on day 14. That means it is a steady state sample for 30 milligrams, and then again it was shifted to 60 milligrams on day 15, and it was continuously administered till day 21, and then sampling was done. So basically we have steady state samples for 14, 21, 14, 21, 28 for cohort 4. So this way I can group them, and also you can see the interdose interval and the steady state indicators have already been mapped. I will go to step 7 directly to show you the tables. I'll come back to this page again. I just want to show one more thing here, the plots. So basically I'm stressing upon this, or adding II and steady state columns to kind of differentiate the samples collected on day 1 and day 14, because we would need individually the AUC values for each of these doses, right? Or we can combine it as well. It's just the way how we want to analyze the data. So basically, if you don't group them by day, you would not be able to get individual lambda z values like this for each of the dosing. So yeah, again, based on the scenario, based on the requirement, you can group them based on day, or you can remove the day variable here. So here, if I just remove the day variable and just keep it as it is, so you can see how the plots do change. So it's just day 1 and day 14, day 1, day 14, 21, day 1, day 14, 21, 28. This way, but you will not be able to. So you see, just the last dose or the day 14 dose lambda z you would get. You will not be able to get day 1 dose. So that's the only reason I kind of group them by dose. This is important. You can do that based on the design. So this way you can easily perform multiple ascending dose study non-compartmental analysis in using PumasCP. I hope this was helpful. We'll come back with new videos for different study designs that you can use. Please, if you have any questions, or you get stuck somewhere during the analysis, you can contact support@pumas.ai. We will help you resolve that within a day. Thank you so much for watching.